No, well there, yeah.
Just get started.
Yeah. Good morning, everybody, and a very warm welcome to the thesis defense for Luz Rello, who everybody knows, I guess. Well, you maybe don't all know the board, so I better introduce us quickly. My name's Peter Gregor. I'm from the University of Dundee in Scotland, and I only just got here because of the French air traffic control problems. There were very few flights leaving the UK, but mine did. Anyway, that's irrelevant. Antonia Marti is from the University of Barcelona and is a member of the board. And the secretary of the board is Josep Blatt, and he's from this university and promises me he'll keep me right. Okay, now, I think it's best if we keep this as an informal event as possible. What happens is that I will invite Luz to present her work, and then the board, in turn, will ask questions, and that's just the way it'll go. Now, I'd also like to invite the supervisors, Rick and Horacio, to join in the discussion if they want to. So please feel free to do that. Right, I think that's enough. If I missed anything. No, I got it right so far. Thank you. Luz, I think over to you, please. And could you please talk to us about your work?
Thank you.
And we'll just move around here so we can see what's going on.
Thank you for being here, committee, and thank you for everyone for being here. It's my pleasure to defend my PhD thesis today. This is DysWebxia, a text model accessibility for people with dyslexia. This was supervised by Ricardo Baeza-Yates and Horacio Saggion. So, the outline of the thesis. Very simple. So first I'm going to speak what is the thesis about, then why did we decide to do it, and then how we did it, centering in understanding dyslexia, text presentation, text content, and then the integration of the results into tools. So the main goal, to improve accessibility of people with dyslexia. Secondary goals, okay, to do so, we want first to understand dyslexia by analyzing the reading and the writing of people with dyslexia. Second, we want to find out the text presentation parameters which are optimal, which benefit the readability of people with dyslexia. Third, we want to find out which are the content modifications which benefit people with dyslexia. And fourth, we want to take the positive results out of these experiments and integrate it into tools for people with dyslexia. Why? Dyslexia. Dyslexia is a learning disability which is characterized by poor decoding, poor word recognition, and poor spelling. And dyslexia is much more frequent, as we all think. It's about 10% of the population. You have here different statistics depending on the country, depending on the language. And it's not about letter reversals. It's a universal cognitive disability. It has a neurological origin. And the most serious thing is that dyslexia is related to a school failure. In Spain, 25% of the students do not finish secondary school, and in Europe, 15% of the students do not finish secondary school. And today, also, the most frequent way to detect a person with dyslexia is due to their school failure. Access to information is also a human right recognized by the United Nations. We also know, based in previous research, that what is good for dyslexics is also good for all. And now is the right moment. Now we read more on screens than on paper. And, well, because of the digital format, we know that now everything can be changed automatically. the design and the content of the text. So what we need to know now is what to change to make tests more accessible for people with dyslexia. So this is a multidisciplinary challenge. We first wanted to know which are the problems that people with dyslexia have, so we review cognitive neuroscience literature. We also wanted to find out whether there were linguistic foundations in the reading and in the errors that people with dyslexia write. We want to find out how natural language processing, so how the modification of the content can help for people with dyslexia. We want to find out how the presentation of the text can help people with dyslexia, and we are doing this with a new methodology used for this purpose, which is eye tracking. So when we read, we don't read word after word, syllable after syllable, letter after letter. We read like this. This is each of the points that you can see is a fixation point. This is how a person without dyslexia, we're seeing here a standard reading, read a text. So what we do, we record the readings of people with dyslexia, people without dyslexia. We change the conditions of the text. We analyze this data and then find out which are the parameters that lead to a significantly better reading and integrated in tools. So, for doing so, for each of the conditions that we studied, we made one experiment. In these experiments, each of the experiments, we had in between 23 to 56 participants. They were all native speakers of Spanish with diagnosed dyslexia. And for each of the experiments, we also had a control group map with their education and also their ages. And this control group were people without dyslexia. So we made people to read text. So then to be able to compare these texts need to be comparable from a linguistic and from a cognitive point of view. So this is why all the texts that from each of the experiments have the same genre, had the same topic, had the same number of sentences, the same number of words. They were comparable. The words had a similar word frequency, they had a similar word length, and they had the same number of numerical expressions, the same number of foreign words, the same number of name entities in the text, because all these parameters have an impact in the readability of the text. So this is why then later we can compare the text. And for each of the texts we have a condition which is modified. The text presentation is controlled. The comprehension of the test is measured via questionnaires, so different kind of questions, literal questions, inferential questions, memory questions. And the subjective ratings were taken via Likert scales. So, the design of the experiments. We always try to make a within subject design, so we know this way that the results are not dependent on the group, but on the conditions that we want to test. We only had to make one experiment, which was not possible to have a within subject design, so we perform a between subject design. So, okay, very important here. The variables, the dependent variables, what are we going to measure? So we have both. We have quantitative measures and qualitative measures. And for both measures, we're going to measure readability and comprehension from an objective point of view and from a subjective point of view. Readability, from an objective point of view. What we did, we took the data from the eye tracking. So we took the reading time, the fixation duration, and the number of fixations. For the comprehension, what we did, we used the scores of the comprehension test. This is the quantitative data. The qualitative data, okay, we are going to measure the readability and the comprehension and the preference, the subjective perception of the people via Likert scales, via ratings of the participants. And then we're going to compare both data, qualitative and quantitative. And depending on the design of the text, of the experiment that we have done, we will apply the corresponding statistical test. So, now let's go to the core of the thesis. We are going to start first from understanding. So what have we done to understand dyslexia? Here we're going to see cognitive neuroscience and linguistics. So we decided to take errors, written errors of people with dyslexia as the starting point, because errors are a source of knowledge and they are very valuable. Errors are being used for studying dyslexia, are being used for diagnosing dyslexia, are even used for accessibility tools, and we are going to find out what do we do with these errors to find out linguistic foundations of dyslexia. So first we use these errors to map the web and find out how many texts were in the web written specifically by people with dyslexia, and we found that at least 0.5 of the texts that we found in the web were in the Spanish and in the English web were written by people with dyslexia. Then we analyzed the errors from all the points of view that we could thought of, from a phonetic point of view and from a visual point of view, and we found out that errors written by people with dyslexia were linguistically motivated and visually motivated. So we tend to have more errors in letters that have rotation and mirror features, and there are more errors in letters that share more phonetic features. So now, please read this test as fast as you can. Right? Right. You finished, right? How many errors had the test? Did you see any? No? Come on, you have seen the errors. You have no dyslexia. Well, half of you at least don't have dyslexia. Okay. So this is one of the experiments that we did. First, we put a text with errors. People didn't know that the text had errors, and then we ask after the comprehension questions, how many errors did the test have? And people without dyslexia were, oh my God, the test has so many errors. This is, it was hard to understand. And then people with dyslexia were like, no, they were not errors there. I was like, okay, don't worry. We have a second chance. We're going to put another test, another text to read, and it's going to have errors. So read and focus on the errors. And they read another text, and the text had also the same amount of errors, and we're talking about 16% of errors in the text, and we're talking about these kind of errors that you see there. I mean, very strong errors written by people with dyslexia. And what happened after this test is that people without dyslexia found that most of the errors of the text, while people with dyslexia still didn't have a conscious perception of the text. We analyzed the data, and we find out that they don't only see the errors consciously, but also this didn't have an impact in their comprehension abilities. So we are here under the first condition that people with dyslexia read better than people without dyslexia, if the texts have errors. Okay, we couldn't believe the results, and we decided to make another experiment. This time with more errors, with text with jumbled letters, and also text with less number of errors. So here you have the famous Cambridge study, which was never done in the University of Cambridge, by the way, that it's around the web. And we made people read these kind of errors with shorter words, with longer words, and with more than 100 participants. What happened? You won't believe this. It doesn't matter how many errors have the test. It doesn't matter the order of the letters. It doesn't matter almost anything. For people with dyslexia, they read exactly the same. Their comprehension of the text is exactly the same. While for people without dyslexia, when the texts have errors, their comprehension decreases, and then when they got used that, okay, right, so this is about jumbled letters, okay, then the comprehension rises again. So here's what we listen all the time. So people with dyslexia cannot see the errors. Right, but we have this recorded in the eye tracking. And what we found out is that they actually see the errors. You see? We have significantly longer fixation durations in people with dyslexia and without dyslexia. So people with dyslexia see the errors. We don't know what happened there, but they are not perceived consciously, and more importantly, they don't affect the comprehension of the text. Contributions of understanding dyslexia. So we know that the presence of errors doesn't affect the readability of people with dyslexia, the comprehension of people with dyslexia. Normally written tests create more difficulties for people with dyslexia, but not for people without dyslexia. But texts with jumbled letters create the same difficulties for both people. So lexical quality is a good indicator for text comprehension, but comprehensibility, but only for people without dyslexia. We know that written errors by people with dyslexia are linguistically and phonetically motivated, and we know that we can use errors also to detect text written by people with dyslexia in the web. Text presentation. So, what we want to find here is which are the text presentations, the design of the text. How can we modify the text to make it more accessible for people with dyslexia? And we studied the following conditions. We studied the effect of font size, we studied the effect of font type, how does the different scales of gray affect in the font and in the background. We study color pairs, we study character spacing, line spacing, paragraph spacing, and column width. I'm going to focus only now in font size as an example. So, why did we decide to study fonts? So, fonts is a hot topic in dyslexia, believe it or not. So there are many recommendations. There are many recommendations of font types for people with dyslexia coming from different institutions, public institutions, private institutions. There are even fonts designed for people with dyslexia, specifically designed for people with dyslexia. And these fonts cost around 500 euros per family. And there are a few user studies, but these user studies only take into account 2 fonts and maybe one font that was designed for people with dyslexia and another font. So what is missing here? What is missing here is first, evidence, quantitative data about how fonts affect readability and understandability of people with dyslexia. It's missing a study with many participants, and also to do this study with the most frequent fonts, to find out how the most frequent fonts affect readability of people with dyslexia, so we can find out what is really useful. So here are the fonts that we studied. We studied 12 fonts. So we studied, as you can see, Arial, which is the most frequent font on screen. We studied Times, which is the most frequent font written on text, and we studied Courier, which is a monospace font, Garamond, Helvetica, Verdana, basically the most frequent fonts that we found. And we also studied how the style of these fonts affects. So they were in italics or not in italics, they were monospace, not monospace, or if they have serif or not serif. So here you have the details of the experiment. So basically, the participants, 96 participants, had to read 12 texts, each of them written with a different font, and of course the conditions were counterbalanced. Let's see what happened. If we take into account the fixation duration, we found that Courier was read significantly faster than Arial, that Open Dyslexic, Computer Modern, Times Italic, Garamond, and Arial Italic. The same with Helvetica. Helvetica also led to significantly faster readings, more than Computer Modern, Garamond, and Arial Italic. And Arial was also led to faster reading than Computer Modern. On the other hand, avoid Arial Italic. So Arial Italic led to significantly lower reading for people with dyslexia. What you can see here is a partial order if we take into account both in the dependent variables, if we take into account reading time and preference rating. And here we can see taking into account the pairwise comparisons in the statistical text, and we can see here how can we relate the significance between the fonts. And here we can see that Arial, Helvetica, Verdana, CMU, Times, and Open Dyslexic are recommended fonts for people with dyslexia. So we also compare it with our control group, and with our recommendations is to use Roman fonts, sans serif fonts, monospace fonts, and Arial, Courier, Computer Modern, Helvetica, and Verdana. And of course, font type has a significant effect on readability on people with dyslexia. From the rest of the conditions that we tested, we only found significant effects in font size, in character spacing, and in line spacing. So we took both font size and line spacing and made another experiment on the web, taking into account Wikipedia, making an hybrid measure design mixing both conditions. And what we found is that for everything, for readability, for comprehension, and taking into account also the subjective ratings, the optimal font size for people with dyslexia reading the web on a screen of 17 inches would be 18 points, or around 18 points. And right now we're working on making this a standard of the accessible web. So, what can we say about the text presentation I mean, how can we make a text accessible for people with dyslexia, taking into account the presentation of the text? So we know larger fonts increase the readability of the text of people with dyslexia. We know that a slightly larger character spacing also increases the readability of people with dyslexia. We know that for web text, 18 points is the optimal size for people with dyslexia. Sans serif, monospace, Roman types benefit the readability of people with dyslexia. And Helvetica, Curiel, Arial, Verdana, and CMU also improves the reading performance of people with dyslexia. Text content. So what we want to find here is, okay, the design of the text, right? But what if we modify automatically the content of the text? Which modifications of the content of the text can benefit people with dyslexia? Because if dyslexia is a reading disability that affects to language, not only the design of the text can have an impact, but also the content of the text. So how natural language processing could help for people with dyslexia? So first, we have here all the dyslexia-related difficulties that we could find related to the content of the text. We took this from cognitive neuroscience literature. And then we map each of the difficulties that people with dyslexia have according to the language level. Then we also map the strengths that people with dyslexia have. So they are strong visual thinkers. And then we were like, okay, so if we take into account these difficulties, which are the potential NLP methods that could help people with dyslexia? Text modification methods. So we know that maybe lexical simplification would help if they have problems with long words, with infrequent words. We know that syntactic simplification might help. Discourse simplification, and any features related to corpus analysis. So, okay, so if we have these potential NLP methods, which are the parameters, the conditions that are involved there, so we can find out what is useful and what is not useful. So here, we took into account the errors. You have already seen the experiments of the errors. We took into account word frequency, word length, numerical representation, so whether the numbers are expressed in digits, are expressed in letters, are expressed in percentages, fractions, how this affects to the readability of people with dyslexia. Paraphrases, so saying the same thing with different words. Graphical schemes, adding keywords. And now I'm going to focus only in the experiment that we did with word frequency and word length. Details of the experiment. So we had people reading both kind of text with long words, text with short words. They were all synonyms. Text with more frequent words, text with less frequent words, and they were synonyms. What we found is the following. If you see, the purple dots are people with dyslexia, the gray dots are people without dyslexia. And what we can see here is that the more frequent the words are in a text, the readability, the reading performance of people with dyslexia approaches to the reading performance of people without dyslexia. And this happens in a significant way. So what we want to find out is which conditions make the purple dots coming closer, significantly closer to the gray dots. And in this case, with more frequent words, it happens. We also find out that shorter words improve the comprehension of people with dyslexia. However, these results must be taken with care, because we know that in language, frequency and word length are naturally related. So less frequent words are longer words and more frequent words are shorter words. So these results shall be taken with care because of the nature of language. Right, but we know that potentially lexical simplification could help for people with dyslexia because it leads to a better readability when the texts are presented with simpler words. So now we need to find out how to make this lexical simplification really useful for people with dyslexia. So what has been done so far in lexical simplification? We have automatic lexical simplification systems. They are done in English, not in Spanish, and what they focus is in detect complex words and substitute them automatically by simpler words. Then from the experimental psychology and word processing, we found many studies that take into account word frequency and word length, but they don't perform these changes automatically. And from the accessibility, most of the accessibility studies that take into account people with dyslexia are more focused in the design of the text and not in the content of the text. So what we want to do is to find out, and also the interaction of the people with the simplification system has not been measured. So we want to find out how to make this interaction and how to make this useful. So what we did, we make one experiment, another experiment, where people had to read original text, so text without modifications, had to read a gold standard text, so texts that were modified manually, and had to read the texts that were modified automatically. We perform an automatic lexical simplification of the text, and texts that they could see the synonyms on demand, but the substitution was not performed automatically. And we did this to warranty that it was device-free, device-independent experiment. We did this in a computer, in an iPad, and in an Android device. They had to read long text coming from Scientific American, but they could choose the text what to read. So we this way warranty the engagement of the participants. And of course, they didn't know anything about the conditions. Believe it or not, what we found is that there were no significant effects on the readability, on the comprehension of people with dyslexia, even if the test, with any of the modifications. However, we found that from a subjective point of view, and this is the only experiment that we have significant results from a subjective point of view. From a subjective point of view, people with dyslexia perceive as significantly simpler, as significantly more readable, as significantly more comprehensible tests that show the possibility of having synonyms of the man. So if they had the possibility of seeing the synonym of the man, even if from an objective point of view it didn't increase the readability, they felt it as easier to read and to understand. So, okay, so lexical simplification from an objective point of view doesn't do much. We cannot know. But if we take into account the interaction of how this lexical simplification is performed, it can be significantly more useful. At the beginning, we were discouraged by these results, but then mothers, fathers with children with dyslexia told us that this can cut with the vicious circle of children reading less because they don't like to read, they think it's very difficult, so they read less, so they read worse, so they read less, so they read worse. But by this, we can cut this vicious circle. So after speaking with the families, we decided to carry on with these results. So this is why we decided to implement a resource of synonyms of people with dyslexia so it can be integrated and used in tools for people with dyslexia. So then we go through the resources for lexical simplification in Spanish and found out that there were not many. So we don't have simple Spanish Wikipedia, otherwise we could perform machine learning and have the lexical simplification from there, very simple. We have a very small corpus, simplex corpus. This is about 200 new tests, so not enough. We have the Spanish Open Thesaurus, so this is from Microsoft Word, the synonyms that you can find in Microsoft Word, so we can use that. This is for free. And we have EuroWordNet, but EuroWordNet doesn't have a good coverage in Spanish compared to English. So what is missing is a resource made of synonyms ranked by simplicity for people with dyslexia. And this is what we did. We took all the corpus of Google Books Ngram corpus, and we extracted here the third term. This was going to be our target word. So this word, that word is the candidate to be a complex word. So we took all these words, we filtered there, we found out whether they were valid words, we found out whether they were not proper names, whether they were not stop words, we filtered them. And then we found out whether these words were complex words or not complex words. So for finding this out, we mapped these words with their web frequency And at the same time, we took into account a list of sentences. So we have a list of sentences. So we have all the words listed in different sentences. We can find different words in different senses because, words are ambiguous, so they can have different senses. And we map each of the words in each of the senses with the word frequency, with its word frequency. So, assuming that we have a word which is complex, then we need to perform disambiguation. So to do so, what we took into account was the frequency of the word in this context and the frequency of the other words which are in that sense in that context. So if we see all the senses where this word appears, we will take the sense that have more words with that context to perform word sense disambiguation. And then we have the synonyms. So we need to rank them by simplicity, by complexity. So for this, we took into account the analysis of the corpus written by people with dyslexia to extract the features to rank the synonyms in complexity. And what we have here is CASA resource. So for example, you have here fortune, we have here the word, we have here the context where this word appears, and we have the more simpler synonyms for this word in this context. And then we have the lemma. It can happen even if Google Ngram books take into account 6% of all the books that has been written in all history. This is 300 gigas in text, but it can happen that the context does not appear. It doesn't have a perfect coverage. So what we do here is to have a baseline that takes the most frequent words of the complex word without taking into account the context. And we evaluated doing an online test this time with people with dyslexia and with strong readers. So people had to do a test online and rank the synonyms on demands that appear, taking into account whether they were synonyms or not, so if there was meaning preservation of the synonym, and taking into account whether the synonym was simpler or not. And what we found is that CASA disambiguated outperforms CASA baseline, so it makes significantly simpler synonyms and more accurate synonyms than the most frequent synonym. And this is a very hard to beat baseline in an ACL CER task in 2012. Out of 9 systems in English outperformed the frequency baseline. So this is quite good. And we make two groups. Complex words, which were like, complex words, and then very complex words, so words that were very, very infrequent. And we compare both results, and for the most infrequent, for the most complex words, the results were better. So, out of all the conditions studied for the text content, we have significant results for both frequency, for word length, for numerical expression, graphical schemes, and keywords. And these are the contributions. First, frequent words improve the readability of people with dyslexia, while shorter words improve the comprehension of people with dyslexia. Numbers presented as digits instead of words and presented as percentage instead of fractions improve the readability of people with dyslexia. Graphical schemes improve the subjective readability and comprehension of people with dyslexia. Highlighted keywords improve the comprehension of synonym with dyslexia. And lexical simplification helps showing simpler synonyms only via synonyms on demand at this time. Maybe in the future, with better NLP lexical simplification systems, we can perform substitution automatically. Right. So, what do we do with all this? So we know what is good for the text presentation. We do what could improve in the text modification. We want to integrate both the positive results of the presentation and of the content of the text in guidelines to present text in a more accessible way for people with dyslexia, in recommendations, and in tools. So here you have the guidelines of text presentation for people with dyslexia, for fonts, for kind of fonts, for font size, so in between 18 and 22 points, for line spacing, for character spacing. We already gone through this. And we also have the text content recommendations to present text for people with dyslexia. So frequent words, short words, digits and percentage try to highlight main concepts in the text, and if possible, to make graphical schemes out of the text. And what do we do with this? We want to integrate it into tools. So first, we integrated together with Accessible Systems India in Mumbai into an Android reader. So you can download an EPUB, PDF, and it automatically renders the book into a more accessible form for people with dyslexia. And it has already 35,000 downloads. And it was finalist of the Vodafone Foundation Accessibility Award of 2012. DysWebxia. So the same as for Android, we have very soon in the App Store the DysWebxia reader for iOS. So this is the same. We took the significant results, we took the parameters, so people can customize the parameters that we know that benefit people with dyslexia, and it has also integrated CASA resource, so it shows more simpler synonyms on demand when people are reading a book, a text, whatever they want. And text for all, so we have Android, iOS, and now the web. And this was developed by Vasil Topac in University Polytechnic of Timisoara in Romania, and it's a web server where you can see it has also the simpler synonym result integrated, and you can search the name and check for simpler synonyms while you surf the web. If we make a tool overview, we see that the most successful tools, or the most popular tools like Amazon Kindle or Apple iBooks, are very close to be accessible tools for people with dyslexia if they include some of our recommendations. But so far they are not ready. So if we make an overview of the tools, we see that IDL and Text for All take into account all the parameters. So ongoing work. So what we are doing now is the recommendations that you have seen for text content and for text presentation are being now adapted in the Generalitat. In the Department of Education of the Generalitat for showing the exams for children with dyslexia and also for the materials in the class for children with dyslexia. We are also collaborating with TechnoSite in Cloud for All project, and this will give the possibility of having a user. You can in any computer in the world surf the web and have your parameters that are good for you, specifically for you. And we are also working in the Web Accessibility Initiative on making the results that we knew that were good for the web, to make it standards of the accessible web. So the main contributions of this thesis were that what happened? Errors. We know that errors are processed differently from a reading point of view by people with and without dyslexia. We know that written errors are phonetically and visually motivated. We created a model called DysWebxia that integrates text modifications from a design point of view and from a content point of view, and this has already been integrated in 4 tools. And as a byproduct, we created 2 resources that can be freely used by anyone in case you want to make more accessible tools for people with dyslexia. This list, which is all the corpus of errors written by people with dyslexia and its analysis, and CASAList, which is the resource of complex synonyms and simpler synonyms, and they are available for free in the web. And all this work could not be possible with all the people listed here that have helped us to make this possible, with the only reward of helping people with dyslexia. So I'm very thankful to all of you. So thank you very much.
next part of this meeting, we will ask you some questions about your work, and I hope you'll answer them as clearly as you describe your work. So I think, can we start off with you, yourself?
Yeah. Okay. Okay. Thanks for the presentation, and thanks for the excellent thesis. Congratulations to you and your supervisors and everybody who has helped. Okay. I don't really have questions about the thesis. I have questions surrounding the thesis. Okay, because somehow the thesis is very, very interesting. Sort of my first question is related, is connected to your work, but somehow connected to the neuro aspects and whether you've thought about using that for rehabilitation. Okay, somehow now you are making things more accessible, but somehow from the background of your work, that might be hinted, and then somehow I would like to know more about that.
Okay. Yeah, great question. I want to do that. There are very few studies that have done brain image, taking into account the condition and then what happens in the brain after the conditions. I only know 2 studies that have done that. More of the studies see people with dyslexia in the wild and people without dyslexia in the wild, and because these studies take well, they're very expensive to make brain imaging. We're talking about millions of euros for doing these studies. I couldn't do it, but I contact the person for the neuroscience research group in the Basque Country. They're leading in brain images, and ask them if they would like to do this in the future. And they explain me, yes, but we need a lot of funding. And we need something very robust to test. So here there are many conditions. To test a tool, there are many conditions that they need to test. Conditions even more in detail than what we have done. So instead of maybe word length, to test how syllable frequency affects language, or how certain letters affect readability or comprehension. But this, this would be amazing to do in future work in collaboration with cognitive neuroscience groups.
Okay, thank you. My second question is you've somehow related to that, and then even you've mentioned it. I wanted to ask you more about the sort of, again, the out of the lab experiments. I don't like very much the term in the wild. Okay, sort of saying that real life is in the wild makes sort of research seem sort of a little bit crazy, you know. Somehow out of the lab in sort of long-term strategies. Okay, somehow. For instance, I liked your mention about engagement in when you were presenting, because somehow the other issue for reading or something like that is things related to motivation or emotional components or things like that. And then somehow most of your work has been really sort of lab experiments. And then I wanted to understand more what you thought about out of the lab. Yes. Or long-term, or
yes, yeah, definitely. Lab experiments have this weakness, so they are valid in the lab for the lab conditions, and we haven't made like a specific test to see the evolution of each of the participants, but most of the participants that have participated in our experiments have participated since 2011 till today. And some of them, they are sit here, have only from a qualitative point of view and from their personal perspective how much they have improved using, start reading on a screen and being able to modify text on a screen. But we don't have, this is a challenge that.
Got no more questions. Thanks very much.
Thank you.
Thanks, Joseph. Tony.
Thank you. Well, I would like, first of all, to thank you very much for inviting me to be a member of this committee. I liked this thesis very much and enjoyed reading it very much. So I want to congratulate the author, Luz Rello, and the two advisors, Ricardo Baeza and Horacio Saggion. I will give you a general comment about the thesis, and then I will make some small remarks about formal questions, and finally I will ask you some questions and make some general comments about specific subjects regarding the content.
All right.
Okay? Well, the general comment is that I was especially impressed by the quality and quantity of the results of the thesis, and by the prestige of the journals and conferences where they have been presented. So, well, it's really a very nice work. I think sometimes you are very daring in many of your statements, and maybe some of them might in the future be refuted. Why not? It could be. But this is not the important thing. I think that the most important is that everybody working in this field will refer to your work. I think this is a seminal work, and everybody working on dyslexia will refer to it. So I think this is very important about you did in this research. Well, let's go now to the formal questions, just to tell you something that can be improved and something that I liked very much. For instance, the organization of the thesis. Each part has an introduction with the contributions you did in this part, and then each chapter has rated work, what is missing, so it's a good way to express that, and your contributions. So I liked very much this organization. It helps a lot the reading of the thesis. Regarding the experiments, you say, well, you conducted 12 experiments and I think 11 sub-experiments, but you didn't number them. So for me, I would like to have a numbering of the experiments, because it can help the reading. So this is one thing you can take into consideration. Then you conducted a lot of experiments and you obtained a lot of results expressed by means of tables and figures. Okay, sometimes the explanation you give in the text is too compact. So at the end, after reading a lot of experiments and results, and the explanation sometimes is short, it's compact, because, well, otherwise the thesis will take a lot of pages. So, but sometimes are a little difficult to understand, okay? More explanation would be helpful.
Okay.
But well, it's okay for the future. Another reading problem is the interpretation of some line graphs without color, because they are in degrees of gray. So, well, okay, I understand. Okay, these were the formal remarks.
Yeah.
Okay? And now let's go to the content. Okay. Well, in particular, I was impressed by the results presented in chapters 4, especially 4, 10, 13, and 14. But chapter 4, I like it very much, because maybe I'm a linguist, and maybe this is a chapter more related to what I do in my everyday life at the university. For me, the most striking statement you made in the thesis is that the presence of errors written by people with dyslexia in the text does not impact the reading performance of people with dyslexia, while it does for people without dyslexia. Well, intuitively, this statement, well, impressed me very much. I have the intuition that this is a really important finding. And the question, if you want, you can answer now, is that what lines of research are opened in the light of this finding? And what theoretical impact does it have on our understanding of the phenomenon of dyslexia?
Yes.
If you have something to say now,
yes.
Okay. If not, in the future.
Yes, I think it opens a way of studying dyslexia. So also not only from a psychologically or a cognitive point of view, which there were already some studies in this line, but also from an accessible point of view. I think not only from a theoretical way, but it has also social and practical implications. Mm-hmm. Because, for example, right now at school, children with dyslexia, they have less grades because of written errors, or in the access to university, they have. I mean, if you have if you have errors, you have less grade, and these findings show that we don't know exactly why, but they don't process these errors the way people without dyslexia think, and the rating system is done by people without dyslexia. So I think that the social implications of these results are very strong, because this means that maybe we need to rethink how to evaluate people with dyslexia, because they access to the test in a different way. Maybe the order of the letters do not have so much importance. Maybe they have an holistic way of accessing the test, of accessing a string. So I think the social implications also are very important, I think.
And theoretical.
And theoretical, yes, of course.
Thank you. You conducted an experiment to find out how many of the web errors were dyslexic errors.
Yes.
Okay. You got a result between 0.67 and 0.43. Well, is there space for random errors in this model? Because, no?
Yeah.
Or what do you think about it?
What happens, this is a lower bound first. So this is the least errors that are possible, so a lower bound. Okay, so for doing so, we made a linguistic analysis of the errors, and we classified the different kind of errors. So we, out of all the errors that we could find in text written by people with dyslexia, we took out all the errors that could be due to typing, so all the letters that are close to them in their keyword. Then we took out all the errors that could be due to not knowing the language. So all the B, V errors, all the H, we took this into account. We also filter all the errors that could be due to language transference. So from Catalan, Spanish, from English, because we did this in English and in Spanish. So at the end, what we had was a subgroup of errors written by people with dyslexia, and this subgroup were only multiple errors, so errors that have more than one change. You need more than one change from the error to the correct word. So this subgroup is safe, but it's a very little group. So this is why it's a lower bound what we present there. Yes.
Okay, thank you. Well, I like it very much. Your proposal for the notation of the corpus with dyslexia. It reminds me what we did with paraphrase. And I found some connections between paraphrase and plagiarism, the work we did with plagiarism, I'm paraphrasing, and the work you did with dyslexia, and summarization as a way of making the reading easier for dyslexic people. Well, we can comment that after, but I will suggest you something, to study about that. This thesis includes also resources and tools as a result. And then, as I can see, there is a social impact because you develop software and resources that can help people with dyslexia. So that makes your work really valuable, and well, I can't say anything else. So congratulations.
Thank you.
That's all.
Thank you, Tony. Like the other two board members, I think this is a terrific piece of work. I'd like to add that it was reading your thesis was like it was like reading an adventure story in the best possible sense of the word. That you know, there was a storyline that I could follow. It was well explained as you went along. And it was full of surprises and the occasional plot twist. So, as a piece of scientific research, I think that's a good thing to aspire to. And so that's not a criticism at all. Right. I'd like to. I think Josep mentioned at the beginning that he didn't have any really substantive issues about your work that he wanted to talk about, and I agree with that. I'd like in that spirit to ask you a couple of questions which are about dyslexia and related to your work, and sometimes quite directly lifted from your work, if that's okay. The first thing that occurred to me was, what order did you do this work in? Is the sequence in the book the same as the sequence in the wild? Sorry, Josep, I shouldn't have said that.
No, it's not. So we first, so what we first did was the error analysis of the written errors. Then from this, and we made the map, the estimation of dyslexia in the web, to motivate the work and to see if it was possible to find users with dyslexia in an automatic way. We found that was not possible. So the rest of the experiments were done. First, I did a first round of experiments that were more experimental. That some of them are not in the thesis, just to find out what was going on with the reading and the readability. Yes, and then we perform them. Longer experiments and more scientifically, sound experiments with font type and with lexical simplification. What also didn't happen at the same time was that the people who developed the tools did this very early. So with the very first results that we had, that at the end we had to change, they were already implementing the tools. So we could have, at the beginning, we could have feedback of the people super fast. So the first year, there were already users giving like, okay, this doesn't work, okay, this do this other way. So this, yes, so we were refining the tools and refining the experiments given because of the feedback of the people. So yes, so there was so in the thesis, yeah, it is presented, in a different way as it was done.
No, I can see why. Okay, thank you. The one very specific thing, well, there's a couple of very specific things I have. In 1.4, you're relating to work in chapter 9. You say sans serif, monospaced, and Roman font types increase the readability for people with and without dyslexia, while italic fonts decrease it. And you mentioned in the thesis, you mentioned good fonts for people with dyslexia are Helvetica, Courier, Arial, Verdana, and CMU.
Mm-hmm.
Now, it seems to me that there you've got examples of serif, sans serif, monospaced, proportional spaced, and I wondered whether there is a property that's not to do with the serif and sans serif or spacing that makes these fonts better, or
so from an intuitive point of view, what we and from what the participants have told me, they prefer these fonts, and preference, not objective data, but they prefer these fonts because they told me that they were clearer to see. And if we go to the fonts, we see that the kerning space in between letter to letter, so the space in between these letters are a little bit larger than the rest of the fonts. And also we have this experiment when we found out that a little bit more of space in between letters also improves readability. So maybe it has, maybe it's related to that, but we cannot make. I mean, to make a statistical test on this is difficult because the condition of the kerning space has not been established from the beginning of the experiment. So now it's not, it's not consistent. Yeah. But maybe it has, from an intuitive point of view, qualitative, maybe it has to do with that.
Okay. One of the things that I think is one of the outputs from your work is a set of guidelines. And I'm quite a naughty person. I'm sure there are other naughty people in the audience. And I like breaking guidelines. Now, and I think everybody's a bit like that, but it's actually a serious point. And I wondered, you can have guidelines and you can adhere to the guidelines and you can produce things that are better, more accessible using guidelines. One of the things I know that you have found in your research with dyslexia is that it's a very diverse thing. And sorry to pull an example I know more about. Some dyslexic readers, if asked to choose colours, will choose, as you say in your thesis, like sort of maybe a muddy green against muddy, dirty brown, and others will choose black on white, and others again will choose, let's say, yellow and blue. I think that's another one.
Yeah, that's your work, yes.
Okay. Well, yeah, well, that's what I know more about. So, it's. And you can't set a standard for that, you know, because everybody's different. And I wonder, the question is, how do you reconcile individual difference with standards?
Yes, this is something that we thought a lot about this because this is problematic, and each person is very different. So the way we reconcile this was to make all the parameters customizable. So each person can customize the way they want. So, for example, with the colors, we had this problem. So with the colors, we found significant differences in their preferences, specifically with the mucky green and brown. But from an objective point of view, from readability, we didn't find any difference. So we didn't know what to do, whether to give more weight to the to the preferences or to the. So at the end, what we did, if you can see here, all the parameters are customizable. So they can, and we encourage in the instructions, customize, find your own. Because of course the analyses are made with means and statistics and yes.
Okay, so. I mean, you could almost claim, in fact, that being able to customize is actually part of a standard.
Yes, yes. And this is another reason why we didn't want to call it guidelines. I said guidelines, but we don't call them guidelines. We call them recommendations through all the theses. And yes, because it's not a guideline. It's a recommendation and a customizable recommendation.
Okay.
Yes.
Thank you.
Thank you.
I'm nearly there, honestly. CASA Is that what you say?
Yes.
And dyslist. I mean, these just looking at the, they're almost mentioned casually in the thesis. Now, these must have been an enormous labour of love producing them.
Yes.
I mean, were they?
They were.
Yes or no will do it.
They were. So implementing CASA was the worst summer of my life.
So
really?
I didn't mean to highlight the worst summer of your life.
It was. I have no words to say how this was.
Yeah.
So it's.
I can imagine. Yeah.
Yes, and I'm not an engineer myself. So implementing this was a nightmare. It was very challenging. Then I received help by Julia Dembowski. She was an intern, an undergraduate intern from Germany, and she optimized it. So it was done, but it took a lot of time to generate, and she optimized it and improved it. And this list was also a lot of work. And here, because of course you need to go through all the tests written by people with dyslexia and extract word by word and analyze
I did wonder
feature by
that,
feature.
yes.
Feature. You did. Okay. So feature by feature. And in this case, I also received help from my advisor, from Ricardo, and from Joaquin Gisterris. He's a well-known phonetician to check whether all the features were correctly annotated, because it's multidisciplinary. So it was not only me. I received help, but yeah, it was very. This was a lot of manual work.
Yeah. It seems to me that in the future it'll be well worth having done it. Maybe not for you, but for other researchers.
Hiring positions.
Yeah. Okay. Right now, a thesis normally, I think, that achieves one thing. It moves forward the bounds of knowledge in a very specific area. And your thesis, it seems to me, potentially moves forward the boundaries of knowledge in quite a few different areas. And you mention in a very quick bit at the end, which is almost like I really need to get this finished, some of the future work you would like to do. Have you thought more about, if you could choose anything in your future career about working in the field of dyslexia, which bits would you pick up on, and do you have thoughts about what you would do with them in the bigger scale, rather than specific eye tracking experiment to identify?
In the bigger scale, okay. So here we have presented suggestions or solutions for reading, and for people who already know how to read, for readers. So in the future, what I would like to focus is for writing and for writers. No? So for people with dyslexia who already know how to write, because word corrector or the correctors do not mark the errors of people with dyslexia. There are many real-world errors. So this is, and also what we have done here are for readers. I would also like to focus in pre-readers, so children with dyslexia that do not know how to read, haven't learned how to read, so make something that can help them to learn how to read, to acquire reading in a better way, and at the same time to early detect how. So because I think the detection can help a lot more. So these are the two very broad areas that I would like to do in my future research.
Yeah, very exciting too. Can I ask you one more thing? Or
please.
This is not to do with your thesis particularly, but as one does, when I got your thesis to read, I had a quick look on the web to find out if anything has come out very recently that couldn't possibly have been in your thesis. And I found one thing, which I think you might know about. It's a book which I think is called The Dyslexia Debate by a guy called Joe Elliott. And he says that the term dyslexia should be abandoned as it lacks scientific rigour and educational value. And it goes on to comment. Dr. Gay Keegan, who is a district senior educational psychologist in Hampshire, says, As an applied educational psychologist, I do not find the term dyslexia helpful, since there appears to be no unifying etiology identifying characteristics, prognosis, or response to interventions which all people with dyslexia share. So rather than considering a single entity, I find it helpful to consider different reasons for reading difficulties using a functional analysis rather than looking for a label. My approach involves assessing what the child can do and what they find difficult, assessing and enhancing their learning opportunities, and measuring their response to well-delivered, evidence-based interventions over time. And I thought, oh yeah, okay. What do you think?
Well, actually, I kind of agree, because of the variation, of the great variation of my participants, I had the feeling only from, I mean, they were all diagnosed with dyslexia, officially diagnosed with dyslexia, but I have the feeling that they were very different. And maybe with the same word, we are putting together different difficulties. So, you know, when we read, many things need to happen in the brain perfectly matching at the same time. So we need to map sound with a letter. We need to be able to put the letters in a certain order. We need to find a pattern in the letter and distinguish this letter. So many things are happening there while we read, and maybe dyslexia is an umbrella where all these little mismatch happen. And there are also many comorbidities with dyslexia. So you have visual stress syndrome, you have dysgraphia, there are so many comorbidities that also make it very difficult to So I agree. The only thing is, from a theoretical point of view, this is great, but from a practical point of view, if you want to study something or to propose to help a group, you need to make a group, no? So, yeah, we will see what happens in the future.
I completely agree with everything you just said there, actually, yes. Okay, well, that's all I want to ask you. Thank you very much. Can I ask now, are there any other doctors here who would like to ask any questions? Or make any comments?
Well, I would like to make a comment.
Okay, well, you can make a comment as a doctor or as an advisor. Or both.
I'll wait.
Okay. No, go ahead.
Okay, so a few things. First, I would like to thank the jury. So thank you, Antonia, thank you, Peter, and thank you, Joseph, for having assessed the dissertation. Then I would like to say that I am extremely proud of what Luz has achieved today. I think it's clear that she has bring together people from different fields in order to achieve what she has achieved. And I would like to say finally that I am extremely honored to have been your supervisor and to have worked with you and with Ricardo. That's all.
Thank you. I think that's a very fitting way to end this session. Oh, no, we're not ending it yet. Ricardo.
I just also wanted to comment something. I think that Horacio took almost all what I want to say, because I was very proud of Luz's work. Thank you for coming here and evaluating it. I guess the only thing is that if I would have expected something when I proposed the topic, I would have never expected this. So this is beyond expectation, and I'm really proud of you doing this research.
Okay. Thank you, Ricardo. That's it. Okay, well, thank you everyone very much. I'm sure that it's been as much pleasure for you as it has been for me listening to the presentation and the discussion. Can I ask you now to leave for a little while the board have a brief discussion, and we'll call you back as quickly as possible. Thank you.